This is Mr. Martin. These are the video notes for section 9.1, radicals and quadratic equations. In the chapter we're going to be looking at the Pythagorean theorem, and it's going to be really important that you know how to work with radicals and that you also know how to solve quadratic equations. So this section is just a little refresher. If you need any extra help, make sure that you come see me or go to the point. So first example, we want to simplify the square root of 128. So one of the techniques that you can use that will work every time is to use upside down division and put 128 into its prime factorization. So we want to divide by prime numbers. So 128 is divisible by 2. 2 is a prime number. So we end up with 64. And then we can divide 64 by 2. We can divide 32 by 2. And so on. For this example, we're going to get a whole bunch of 2's. So you can see we have 7 2's, so the square root of 128 is the same as 2 times 2 times 2, and then 4 more. And then every pair of these really is the square root of 4, and when I take the square root of 4, it's just going to become 2. So this square root of 4 is 2, this square root of 4 is 2, this square root of 4 is 2, and then I'm left with 1 2 underneath the radical. So 2 times 2 times 2 is 8, 8 root 2. So square root of 128 is simplified to 8 root 2. Now if we go back to when we had 2 times 64 here, 64 is a square number. So I could have also done this as the square root of 64 times the square root of 2. And I like the square number because it simplifies to 8. So we have 8 root 2. And this is actually how I'm going to do the rest of the examples, but if you want to do your prime factorization, that's fine as well. So for example 2, we've got 27, and I know that 9 is a factor of 27, and 9 is a square number, so this is the square root of 9 times the square root of 3. And then 16 is a factor of 48, which is a square number, so that's the square root of 16 times the square root of 3. And then 50 would be square root of 25, another square number, times the square root of 2. Square root of 9 is 3, so I have 3 root 3. Square root of 16 is 4, so I have 4 root 3. Square root of 25 is 5, so I have 5 root 2. And then we want to treat these as like terms. So I have 3 root 3 plus 4 root 3, so that would give me 7 root 3. And then I have my 5 root 2 left over, so this would be my final simplified answer. Alright, moving on to example 3. If you want to pause the video and see if you can work it out, that would be great. Square root of 18 is square root of 9 times square root of 2. 32 is square root of 16 times square root of 2. And square root of 75 is square root of 25 times square root of 3. Square root of 9 is 3, so that's 3 root 2. This becomes 4 root 2. This becomes 5 root 3. Again, we're looking for like terms, so I have 3 root 3 and 3 root 3 and 5 root 3. So these two. So I'm going to have 8 root 3 and then 4 root 2 by itself. Moving on to the last example, we have the square root of 7/5. It's simplified form, we can't have a radical in the denominator, so this is really the square root of 7 over the square root of 5. And in order to get rid of that radical in the denominator, we're going to multiply by 1, but in a special form. So I'm going to multiply by that root over itself. So square root of 5 divided by square root of 5 is really 1. But then when I multiply, I've got square root of 7 times square root of 5, which is square root of 35. Square root of 5 times square root of 5, which is square root of 25. And the square root of 25 is just going to simplify to 5. So there's our final answer for that one. So again, if you have any other trouble simplifying radicals, make sure you ask me or go to the point. The next 5 examples, actually, we're going to be looking at solving some equations. It's a couple different techniques. So let's go ahead and look at example 5. We've got 2 root 5 squared plus 3 root 3 squared equals x squared. So this is, we need to square everything inside the parentheses. So this is going to be 4 times 5. And this is going to be 9, 3 squared. N squared of 3 squared is 3, is equal to x squared. So we simplify this. I'm going to flip sides here. I get x squared is equal to 47. And take the square root of both sides. Remember, make sure you do positive or negative. And we get square root of 47. You can just leave it like that. Next example, I'm going to isolate the x squared, so I'm going to add 10 to both sides. So I get x squared is equal to 36. Again, take the square root of both sides, and I get x is equal to positive or negative 6. Moving on, we're going to start factoring. Both of my terms have an x, so I'm going to factor that out. I get x times x minus 8 is equal to 0, and if you remember the zero product property, I have two things being multiplied together here, x and x minus 8. If I multiply two things and it equals 0, that means that one or the other has to be equal to 0. So either x is 0 or x minus 8 is equal to 0. Solving the second part for x, I get x is equal to 8. So here's my two answers. Alright, so that's a rather simple case of factoring. Moving on to the next example. Again, I'm going to try and factor this. That's my first method usually. We'll look at another method in the next problem. So however you learn to factor is fine. If you need some tips, make sure you ask. I'm looking for factors of 24 that when I add or subtract them equal negative 2. So I know 6 and 4 work. And since I need a negative 2 here, I'm going to put a minus, and I'm going to put a plus here. Again, if you need some extra practice on factoring, I can get you some extra practice, but you're going to need to know how to do this. So then again, we have zero product property. We have two things being multiplied together, x minus 6 and x plus 4. Either one of them must be 0 in order for this whole quantity to be 0. So x minus 6 equals 0, which means x would be 6. Or x plus 4 is 0, which means that x would be negative 4. So there's our two answers for this. And you could always go back and plug those in to make sure they work. Alright, so the quadratic formula, if for some reason you can't figure out how to factor, nothing's working, you can always use the quadratic formula. X is equal to opposite of b plus or minus b squared of b squared minus 4c all over 2a. So let's try this with the last example here. I'm going to find out what a, b, and c are, just so I have those to reference quickly. So a is going to be 2, b is negative 11, c is positive 5. So I'm going to plug those in for a, b, and c in my formula. So I get that x is equal to the opposite of b, so that's 11, plus or minus, that's where we get our two answers. We're going to add the stuff under the radical first, then we'll subtract it to get the second answer. The square root of negative 11 squared minus 4 times 2 times 5 all over 2 times 2. So I get 11 plus or minus the square root of 121 minus 40 all over 4, and all of this simplifies to 81. So then I get x is equal to 11 plus or minus the square root of 81, which is 9, over 4. So one of my values of x is going to be 11 plus 9 over 4, which is 20 divided by 4, which is 5. And the other value is going to be 11 minus 9 divided by 4, which is 2 over 4, or 1/2. So there's your two answers. So again, if you had any questions, make sure you write them down and ask me the next time you see me in class. Otherwise, we'll see you next time.